Thank you. So in May 2000, so 14 years ago, I met a woman and she changed my life. So her name is Sibel, and she's what we call a chatterbot. So she's an AI character, and you can chat with her online. First I thought, wow, she's not very pretty, but she's really, really smart. And actually, after a few conversations, I realized, well, she's not so smart, but she's funny, and that's cool. I'm in love anyway, it's too late. After I discovered that, I decided to just do this with my life, to build AI that you can have a conversation with. And so I did that first with, for customer service with Virtuos, in France, and then we moved to the US. And we also did an experiment. You might remember SCAS. They were like your personal bot on MSN Messenger back in 2007. And more recently, with Wit.ai. So Wit.ai, you can check it online. It's basically a Siri as a service. So it's an API that makes it very easy for developers to add a Siri-like speech interface to their apps or device in a few minutes. So I'm not the first one to be obsessed with machines that you can talk to, and you can trace back to at least the Greeks to find gods, like Hephaestus in this case, who was supposed to build, you can see the head over there, to build these artificial humans that could have a conversation with you. But more recently, and I call him the god of computer scientists now, but Alan Turing wrote a very interesting paper in 1950, and the question he was trying to answer is, do machines think? Are machines, what is an intelligent machine? And his answer to this question is a very famous Turing test, and he said, if a human can have a conversation with a machine and the human doesn't realize it's a machine after 5 minutes, then I can say this machine is intelligent. This is what I call thinking, this is what I call intelligence. And so Turing defined intelligence as the capacity to talk with humans. And after he did that, computer scientists became very interested in this question. And as early as 1967, so you can imagine what you used to program in 67, Joseph Weizenbaum at the MIT wrote a simple program called ELIZA that was the very first chatterbot. So this is a virtual psychiatrist, so you can talk about your problems and she will answer, and you can have a almost natural conversation with her. So it's mostly based on tricks. So for instance, if you say, if she doesn't understand what you say, she will say, sure, tell me more about that, or so. But it's based on tricks, but it works well. And ELIZA became very, very famous in '67. After that, Hollywood loved this kind of thing, AI that's outsmarts humans. And in many, many movies, you can see these kinds of AIs after that. So you might recognize HAL 9000 from 2001: A Space Odyssey. So this is a super smart computer that tries to kill the human crew. And this movie was released in '68, so 1 year after ELIZA. I have a short conversation with the AI. Sorry.
Hello, Hal, do you read me? Do you read me, Hal?
Affirmative, Dave. I read you.
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
I think you know what the problem is just as well as I do.
What are you talking about, Hal?
This mission is too important for me to allow you to jeopardize it.
I don't know what you're talking about, Hal.
I know that you and Frank were planning to disconnect me. And I'm afraid that's something I cannot allow to happen.
So it goes on and on, but you remember this conversation with Hal. Another example is Kit in, I forgot the English name for this, but it's K 2000 in France. It's different in the US. So Kit is 1980, and Kit is like Google self-driving car meets super smart Siri. You can find both technologies, and it's funny because Google self-driving car is actually close to Kit in terms of capability, but Siri is very far from being as smart as a car in the movie. So you see that how movies can predict the future in some areas, but not others. Actually, 30 years after these movies, we can see the real world is very, very different, and we are very far away from the promises of Hollywood. I'll show you what would be actually a true HAL conversation in 2001.
Okay, leave it till I do.
Hello, Hal. Do you read me, Hal?
Welcome to HAL. Please listen carefully, as my options have changed. You can say, open the pod bay doors, play chess.
Open the pod bay doors, Hal.
Sorry, I didn't understand. You can say, open the pod bay doors, or press 1. Play chess, or press 2. Learn the Alp horn, or press 3. Around what time would you like the pod bay doors to open? You can say, today, tomorrow.
Now, damn you.
Main menu. Please listen carefully, as my options have changed. You can say, open the pod bay doors, or press 1. Play chess, or press 2. I'm really sorry. Even though your call is really important to me, this mission is even more important, and I cannot allow you to jeopardize it.
I don't know what you're talking about, Hal.
I know you and Frank were planning to press 0 for an agent, and I'm afraid that's something I cannot allow to happen.
Okay.
So I stole this from my friend Roberto Pieraccini, a very famous researcher. But I think it shows well where we went instead of what was promised by Hollywood. You might have voice control in your car. If you type in YouTube like car voice control, the first result you get is something like that.
Media.
Radio.
Nej! Akon, sång, media.
Radio.
Nej! Playlist.
TV.
Nej!
This device is not available.
So I'll cut, but you see you have hours of things like that. So real-world AI-based UIs you find them in call centers, in cars, in smartphones with Siri and the likes, and we have to admit it's a failure so far. So why is it so difficult to build an AI-based UI? First, it's a very hard problem. You need to understand speech, get text from the speech, then to understand the meaning of the text, then to make some reasoning, to decide the action, and then to generate some output, some text, and then convert this text back to speech. It's a very long chain, and if you break somewhere, then everything is broken. So this is extremely hard, and these problems are not solved completely yet. The second reason is you tend to have two categories of users. People who've tried it before, like they had a car 5 years ago, they tried like the guy we saw in the video, and they say, oh, this is shit, it doesn't work, I don't want to use this anymore in my life. So these guys are lost. And then you have other people, like my mother, and if I tell her, yeah, you can speak to your phone, then she will start to ask crazy questions, and she has expectations that we will never meet. So you have these two categories of users, and both are extremely hard to make happy. And the third reason, I think the most important, is all the objects we use in life communicate about their function. You know, if you see a hammer, you know you can use it with a nail or to kill somebody or do something else, but there is a handle, and you know what you can do with it or not. You won't ask a question to this tool. If you look at the computing paradigm based on Windows, you have menu with a list of actions. You know what to do with these things, and you know what you cannot do. If you talk to somebody at Starbucks, you will ask for a coffee, and she will give you a coffee, but you cannot not ask philosophical questions. But if you look at HAL 9000 or Siri, what is the scope of this object? What can you ask? What is not possible? This is extremely hard because this is not communicated by the shape, by the form of the object. So this is a different situation. And yet we have to find a solution, because as our devices become smaller and smaller, we don't have screens anymore, we don't have keyboards anymore. And so for many of these devices, voice and AI in general will be the main UI very soon. So we'll have to find solutions. The good news is that things have changed recently and will make these UIs possible. The first thing is that with smart devices, wearables, home automation, Internet of Things, you can call it as you wish, these devices typically do only one thing. Like a Nest thermostat is about changing the temperature in your home. And this is it. So you won't ask how many atoms are there in the universe to your Nest thermostat, because you know it's a thermostat. So because these objects form and communicate about what they do, and they tend to do only one thing, it's much easier to build AI or speech-based UI for them, because your scope is very small, and you just have to care about this scope. So this is a huge difference. The second reason is last 3 years, major breakthroughs were made in speech recognition. And typically what we call the word error rate, that after 20 years was stagnant, suddenly dropped 15 points 2 years ago, when people started to use deep neural nets for speech recognition. So the quality of speech today is much better. And the third reason is, and this is a good topic for today, people understand that they cannot do everything. If you build a thermostat, if you build a car, you cannot build your AI system yourself. You have to focus on what you do well. And more, we see more and more APIs or communities that try to work together to build an AI that learns from everybody, and to put together all the learnings. And it makes very efficient systems. And this is, of course, what we do at Wit.ai, but there are many other machine learning API on the market. So when developers group themselves and join forces, you get much better results. So to end with a few best practices, if you have an app or a device and you think you maybe will add an AI interface, the first advice I would give is define a reasonable scope and a reasonable goal. So you have to have a limited set of commands, like we saw with Nest. You cannot do Siri. Even Apple has lots of trouble with Siri now, they quality problems. So define the scope that is limited. If you have lots of background noise and the user will speak from 10 meters away from the microphone, and bad quality audio, it won't work. So you also have to be realistic with these constraints. And then you have two options always: the embedded processing, where everything happens in your app on your device, and the cloud-based processing. So cloud-based, of course, it's much more powerful, but you need an internet connection and you have latency. So this is a trade-off between the two options. The second best practice is about user expectations. So we've seen that it's okay to have the same system can be considered a success or a failure depending on how you set your user expectations. And it's very hard to communicate about what your device can do or cannot do, as we've seen in many cases. But this is absolutely key. So for instance, this is a robot that does, so the picture is bad, but this is a barista, so he can do coffee for you, many different options of coffee. Just speak, have a conversation, it will actually do coffee for you. And given the shape of the robot, and we don't see it there, but you understand that it's about coffee. So it's a good example where they were able to communicate to the user, okay, this is what I do. The third one is, don't try to teach your users how to speak. And this is the mistake that most car companies have done. They say, if you want to turn on the radio, say turn on radio. And if you say anything slightly different, it doesn't work. So you have to learn to adapt from users and not the contrary. The best counter example is, you might remember, if you're old like me, the Palm Pilot, and you had to actually learn how to write again, or your pilot wouldn't understand what you write. So this is very bad. Don't try to teach something to your users. They don't have time, they're lazy. So it's another example where a Now robot from Aldebaran is powered by Wit.ai for its speech interface, and they started with an empty interface, and they learn from users what they say, what they want the robot to do, and so they start from scratch based on users' requests. And finally, sometimes the best speech interface is no speech interface. I see many examples where people do a speech interface for their smart home, and so they arrive at home and they turn on the light in the living room. But actually, if your home is smart, it knows that it's dark, it knows that you are in the living room and you need light. So the home should turn on the light in the living room without having you to say it and wait for the result and so on. So it's a very important notion that you shouldn't just try to replace switches by voice command. You have to first think, is it really necessary to have a command to turn on the light? At the beginning of the century, when people started to think about how to build washing machines, for clothes, I saw the first tries were a robot squatting in front of a bucket with arms and doing this to wash the clothes. And so when you enter a new paradigm, people tend to try to just do as before with automated way, and actually it doesn't work like that. You have to rethink the problem from scratch, and this is often through a common mistake we do with AI interfaces. So I'm really convinced that even if it's very hard, as I said, and there are many problems, I don't want to discourage anybody. And I don't know if you saw the movie Her. It's not a very good movie in my opinion, but it's a very good movie for the UI that they show. They just have an earbud, a super smart Siri, and he actually falls in love with her. But the UI is very interesting. And so I'm convinced that in the near future, 2-3 years from now, we'll have audio-only devices where you have no screens anymore, and everything is through speech, input, output. And as developers, if it happens, you will have to build applications for this kind of devices. So it will be very interesting. So thank you very much, and if you have any question, I'll be happy to answer.
Some question there? Who already built an app that was using text to speech, speech to text, or this kind of stuff? Nobody yet? Yeah, you built one? Yeah. And what was your feedback about it?
I tried many solutions. The first one was obviously Google Translate with the online API, which was who made the job done. After that, I tried the embed Windows text recognition, which is very powerful, but you need Windows always up. So it was plugged on a Raspberry just for the fun. So I can't tell anything about production stuff first. but it was a bit fun to begin with this kind of stuff.
Thank you for your feedback. I may have a question about I've read the Siri patent. The Siri patent is 268 pages, so it's quite long. But actually, they talk only about interfaces. They talk only about interfaces, and I think this is where your talk wanted to go. So, do you really think in, let's say, and if yes, when, we will have the only interfaces with machines will be just voice, for example? And will we really change our parameters by saying, okay, more volume, please, and skip this level? I don't like it. You know how we will arrive to this, and if not, where is the limit? So when, where, and how?
So first, we will arrive there, and because we will have no choice anymore, I don't think we'll have this on a mobile phone, because you are trained to use touch and swipe, and it works well. But let's think about a smartwatch tomorrow, or Google Glass, or an earbud like the one I showed. There is actually a Motorola product called Moto Hint, which is just an earbud like that. So for these products, if you want to build an app, like for instance on a Pebble watch, if you want to set an alarm at 12:30, you have 27 clicks. If you're not lucky and it's 12:30, because you have to go to 12 and then to 30. So wouldn't it be simpler to say, oh, wake me up at 12 at noon or at 12:30? So I don't think we'll reach this stage for smartphone apps. I think we'll reach this stage for wearables, because it's just not possible to use a touchscreen to do these things. And it will take, everybody's trying to predict how fast wearables will take off. Maybe 2 years, 2-3 years. Apple Watch will have a big impact on that. And many interactions on the Apple Watch are powered by speech. So I think it's soon. It's not science fiction.
And because I see it for actions, for example, setting an alarm is something that a machine could do in some way, but we still need humans. It's cheaper to do it. But will we use these kind of APIs just for, because your API is quite simple, it's really simple to use, give all the actions and everything. Will we use only for talking to machines and to set up machines, or will we create another kind of interaction? No feeling, nothing. I don't talk about that, right? But will we go more than just setting up things?
Yeah, I think setting up simple actions in machines is the first step, because it's easier to do, and we have to meet users' expectations. But then beyond that, smarter and maybe her-like AI characters will come back, and you will fall in love with them. And I see this coming maybe one day. Interaction. Through interaction, yeah.
Actions, now next interaction.
Yeah, absolutely,
yeah. Thank you for the presentation. I was thinking about, I don't know if you heard about a project called Watson, which is an AI that was developed to play the game, I don't know the English name, but it's Jeopardy in French. Mm-hmm. And actually, I think it's very close to what you're saying, because that robot was able to understand enough of the speech to find the question, which actually is very complicated even for human. And actually, I think it won against human, because it was faster. And don't you think that with all those research, we are quite close to what could be something maybe like, I don't know, what you were talking about? And actually, I was also thinking about for example, the robots called in Iron Man, I don't remember the name.
Jarvis.
Yeah, Jarvis. Don't you think we could be close to that thanks to the work done on Watson?
So Watson is a project developed by IBM, and they spent so far $1.5 billion on it. And actually, yes, they won Jeopardy. So Watson, I'm a little bit skeptical, because it was built for that. And today we can use AI to solve specific problem. And playing chess or playing Jeopardy is a specific problem. And there is a huge gap between being good at one specific problem that you were hard-coded to do, and being like we call artificial general intelligence, AGI, which is a completely different problem, where you learn new domains from scratch, and you become good at problems that you never saw before. And I think Watson is a beautiful engineering fest, but I don't think it's a significant step toward general AI like we see in the movies.
I was thinking that maybe actually we could see that it was developed at first to answer, to find a question to a subject. But if we, like, I don't know, behind the question, we just like develop some, I don't know, like plugins or add-ons, we could actually make him do more than just find the question, but also do it or do an action after that. Maybe, or maybe I'm just like blowing up this or something.
So actually it's really designed to be a question answering system. So everything in Watson is designed to, you have a knowledge base, which is actually the internet, and you have a question, and you select the best answer to this question given the knowledge base. And so this is a very specific problem. It's not useless, but it's hard to generalize on top of that.
Yeah, often when you have the answer and not the question, often it's the opposite, right? Yeah, but yeah. Thank you very much, Alex. Thank you.
Thank you.